So at GCSE you'll have seen the equation of a circle. You'll know a little bit about how we describe the circle line as opposed to any part of its area or anything like that. But I wonder if you've ever been shown or thought about where the equation of a circle actually comes from. So we're going to take a sort of an initial geometric approach to proving this. So I've drawn a circle, a very bad one, but I've drawn a circle. We'll pretend it's an actual one. I'm going to label the centre AB because we know we normally like to think about the circle in terms of its centre and its radius. Radius, I don't know. It's a completely nondescript thing, so we'll call this radius R. And then I have a point on my circle. I'm going to call this xy because don't forget the equation of any line we describe in terms of x and y as a series of coordinate points. So here's one of those coordinate points. We'll call it x, y. Right, now what I'm going to do is I'm going to have a look at the little triangle that is created. Because in theory I could move that xy point anywhere else on this circle. It could go up here or here or here, and I would still have the same R, because the radius is the same. I'd still have the same centre point AB, and I'd just get a new little triangle. So that's what I'm going to look at. I'm going to look at this little triangle here, knowing that it could move anywhere around that circle. So here's my little triangle. I've pulled it out of the circle, so the circle would be running off something like that on it. Here's my radius length. Now, because we're dealing with coordinates, obviously I know that that is a little right angle. And what I want to do is label up the rests of the sides of this triangle. So the triangle height here, this vertical line, starts at B and goes up to Y. So its length is Y minus B. Likewise for the width, x minus a. And so now I've got a right angle triangle where I know all three sides, and I should be able to link those using some standard rules. So we know that Pythagoras tells us that the long side squared, which is r, is each of the short sides squared and added up. So here's my first... Oh, hello, that's not quite right, I'm just completely copying wrong. First short side and my second short side. And there, ladies and gentlemen, is the equation of a circle. Done. So this is the circle centre AB, which is what we set it to be, and radius R. So as long as I can get any equation that's a circle into this form, I can immediately read the centre, AB. Notice it's minus A minus B in the equation, so we take the negatives of those two, so minus A becomes A, minus B becomes B, and square root of any numbers you've shoved to the other side of the equation to give us the radius. Let's do a super quick example of this. So I've got an equation here, x squared plus y squared plus 4x plus 6y plus 3. I know it's a circle because it's got x squared and y squared in it. And I want to know what the centre and the radius of this circle are. Now, we know that to get those two pieces of information, I'm going to need to get my equation into the form x minus something squared and y minus something squared, and any numbers left over will be r squared, and then we can square root those for the radius. So to get this x minus a squared thing here, it's pretty much a complete the square. So I'm going to take, I say pretty much, it is, but we're going to, not quite cheat, but we're going to look at them as two separate ones. So I'm going to take the x terms, x squared plus 4x, and then I'm going to look separately at the y terms, y squared, oh, excuse me, y squared plus 6y, complete the square on each of those, continue to add them, they're always added, then sort out all my numbers and sort of shove everything to the other side if I need to. So on the x's then, I'm going to take x plus 2 all squared. Go back to your completing the square if you're not sure how I've done that, but hopefully that is you're completely happy with that. And then y plus 3 all squared there. Now, what I haven't done on either of these is do the minus b squared type of situation, but I'm going to chuck them both over here. So I'd have minus 2 squared from the x expression. Don't forget to complete the square. I would have x plus 2 all squared minus this 2 squared. And also, I'm going to end up with the minus 3 squared in the y terms. Then I've got the plus 3 on the end, which I had before, and I've run out of room, so I'm going to shut that down there, and that equals 0. So sorting all this out, I obviously want to leave this in brackets. Don't automatically assume you need to expand it out. I wanted these brackets, so we're going to keep those there. I've got minus 4, minus 9, plus 3 equals 0. Okay, one more step to get it into that form. I would definitely recommend writing all of these steps out because it's good for you and it's good for your examiner to follow exactly what you're doing. But more importantly, it is good for you and you can actually see step by step, line by line, what you're doing. So here, minus 4 minus 9 is minus 13, add 3 is minus 10. And so I should be able to move those 10 over to the other side, and I've got this form that I was expecting to get here. So x plus 2 all squared plus y plus 3 all squared, so squared, equals 10. And so my centre is minus 2 minus 3, and my radius is the square root of